Ever wonder how AI systems really make decisions? Like, how do they figure out the best path to a goal without getting stuck in endless loops? Let's explore a groundbreaking concept from reinforcement learning, thought actions, and how they transform decision-making. Imagine an AI navigating a maze. It has two choices: act immediately or pause to plan. This thought action isn't just a delay, it's a structured reflection. But how do we know when this pause actually improves outcomes? That's where this research shines. The paper introduces a mathematical framework called a goal-conditional thought, MDP, a two-stage process where agents first evaluate options, tau 0, and then refine their strategy, tau 1. The core question: when does adding a thought step actually improve the agent's ability to reach its goal? Here's the math that makes it work. If the probability of choosing a thought action, PC, multiplied by the success rate of the second step, P1, exceeds the success rate of the first step, P0, the agent reduces the effective horizon of the problem. What's an effective horizon? Think of it as the number of steps required to solve a task. By pausing to think, the agent can solve problems faster, like choosing between a risky shortcut and a deliberate step-by-step path. Why does this matter? It proves that planning isn't just helpful, it's mathematically optimal in certain scenarios. This could revolutionize AI applications, from self-driving cars avoiding collisions to game-playing algorithms mastering complex strategies. Let's break this down with a real-world example. Picture an AI solving a maze. One version blindly tries directions, bouncing off walls. The other pauses, evaluates paths and plans. Surprisingly, the planner wins every time. But why? The research shows that initializing the AI with a thought state, tau 1, raises its lower bound of success. It's like giving a treasure hunter a rough map instead of random guesses. The study demonstrates that structured reflection, simulated as an internal monologue, significantly boosts accuracy. How did they test this? Take a simple math problem, adding numbers. The no thinking prompt just asks for the answer. The thinking prompt shows step-by-step calculations. But here's the twist: the green text isn't just extra, it's a simulated internal monologue. By forcing the AI to think aloud, researchers found it solved problems more accurately. It's like giving the AI a cheat sheet of its own reasoning. Now let's zoom out. In a tiny grid world, an AI had to navigate from one corner to another. They pre-trained it to associate actions, A and B, with directions. When forced to use these actions at key moments, the AI succeeded almost every time. Even cooler, masking thought actions on other steps so the AI couldn't overthink made it rock solid. It's like teaching a student to pause and plan only when needed, not getting stuck in endless second-guessing. What does this mean? It shows that structured thinking, even if simulated, can dramatically boost AI performance. It's not about making the AI smarter, but giving it a framework to avoid random guessing. And this isn't just about mazes or math. From self-driving cars to medical diagnostics, the lesson is clear. When AI learns to pause, plan, and reflect, it becomes more reliable, accurate, and human-like in its problem-solving. So the next time you see an AI thinking, remember, it's not just processing data. It's taking a step back, like we do, to ensure it's heading in the right direction. And that's a game changer. Want to see how these ideas shape the next generation of machine learning? Stay tuned, we'll dive deeper into the future of AI reasoning.